All right, we are live on YouTube. I think people are, no one's attendees, no attendees in yet, but I'm sure people will be showing up soon.
Yeah, maybe I'll do like a live now tweet or something.
Yeah, here you go. I'll give you the YouTube link so you can do live now.
Good idea. Can people not join the Zoom stream if they haven't? Can they use the same link?
There is a, what is the link? It's in the Zoom, it's in the email, or in the, hang on one second, let me get to the Zoom window.
Hey, Brittany, thanks for coming. We'll give folks another minute or two to roll in here. What? Could you hear my boyfriend sneeze just then?
I'm going to Slack you the, I think it is the same one, but I'll just Slack it to you just in case. That's the link.
Cool.
Folks are joining. I'm going to go quiet now. We're on YouTube. Let me send you that link as well, Andrew, so you can promote that.
Cool.
Or I can do it, but you have the Twitter following, so. All right. The floor is yours, Andrew. I'm going to mute myself and.
Awesome. Yeah. Let's take another minute or two just to let folks roll in. I'm going to make some tweets to let people know that we are currently live, but we'll get started here in a minute. Tyler, do you know the fact that the password is in that Zoom link is not a bad thing? If I put it on Twitter, people can't come in and make sounds anyway, so it's probably no big deal.
Yeah, that should be fine. No, people, okay. Well, they come in, they can chat, so they could grief the chat.
Yeah, let me just do the YouTube then, and I'll repost the registration link. Presumably, it just takes you there.
Yeah, so the registration link would be the right thing to do. Yeah, okay, that makes more sense. Cool. Thanks for catching that.
Cool. Brittany, you and I should chat. I should show you all the latest and greatest with our Grasshopper plugin. I think you'd find it useful, and I'd love to have you beta test it a little bit for us. I'll give it like one more minute and then we can kick off. I think today is going to be a fun one, and I think it'll actually go pretty quick, so we might have time to just like open it up and hang out and chat and answer questions and stuff. Cool. Well, why don't we get started? Thank you all for joining. I'm I'm really looking forward to this one today. I think it'll be a fun one, and it's a good introduction to kind of like how we create C# functions in the first place. And I selected this example in particular because the other day I was building something. I was actually working on our kind of new interior layout tool called Hypar Space. And I really wanted to be able to like load in an image and just trace it in a way that was scaled so that everything would come out in the right size. I've been using like floor plan images that I download off the web to kind of like test out the tool, make sure it produces like reasonable looking results. But we didn't have an image underlay functionality on the platform. And, one of the things that was really cool in that moment was I realized that I didn't actually need to go into any of our core platform code. I didn't need to get into the application code or release a new version of the app that had this functionality. All I needed to do was write a function. And everything that I needed to have this image underlay functionality, I could do from within the construct of a function. If you're not super familiar, a function is kind of like the unit of logic on Hypar. And so anyone can author functions, put them up on Hypar, have them privately, or share them with other people. And so anything that I'm able to write as a function is also something that any of our users could theoretically contribute. And to me, this is what's so exciting about Hypar as a platform, is that anyone can add to Hypar the functionality that they need. And so you don't have to wait for Hypar 2022 to come out in order to get some new functionality. You can just add it or have someone that you work with add it, and you're not limited by what comes in the box. And I think that's a really powerful idea because there are so many diverse and interesting use cases across AEC, and there's no way that our small team could address all of them immediately. And we're working to improve the platform every day, but there are just so many things that people might want to do. And the thing about Hypar being a modular platform where anyone can contribute custom functionality means that you can make it into the tool that you need it to be to get your job done.
I'm gonna give a shout out to Zach Crone. If he ever watches this, Zach, you will remember that a long time ago when Dynamo started, we talked about making a software with no buttons. The joke was, we're going to make a software that when it shows up on day one, it'll have no buttons. And then you have to like use Dynamo scripts to actually like put the buttons in your software. That's kind of like Hypar. It's not going to be no buttons. There's going to be a lot of buttons already out there and created by the community, but then you get to make your own buttons.
Yeah, exactly. I mean, I think like, we see the emergence of all of these really interesting platforms that are kind of like laser focused on a particular kind of automation. Our friends at TestFit are working on, like multifamily residential automation, and there are all of these other applications that kind of aim to bring the power of automation to some problem domain. And, our vision is that Hypar can be the place where many things like that can blossom without having to build your whole platform from scratch.
We should also say, Andrew, like we recognize that there are already like very vibrant communities out there right now where people are building tools and sharing them with each other. The Dynamo community is one of those. The Grasshopper community is one of those. The Revit add-ins community, all the people writing Python on PyRevit. Yes. The challenge, and we say this over and over again, so it bears repeating. The challenge is that it's really hard to get all of those tools shared, first of all, so that everybody in the world can have access to them and search them and find them. And secondarily, it's really hard for those tools to work with each other. So some person in Office A writes a Grasshopper script that does something really amazing. Some person in Office B writes a Dynamo script that does something really amazing. And you would like to put your chocolate with your peanut butter, but you can't because they speak fundamentally different languages. Nobody's thought about the contracts with how these things would communicate with each other. So we're not like trying to say we should immediately replace all of those platforms that are being used in AEC with this thing. But we're just trying to solve some of the fundamental problems that people have around, giving people access to their stuff, making it super easy to access that stuff because you could do all the compute in the cloud. You don't have to like install anything. And then being able to connect that stuff into larger workflows. So we don't have to rebuild the wheel. But that's the standard sort of Hypar pitch.
Yeah.
I'll shut up now, Andrew. Do it.
So the thing that I want to build today, I've already built it once. And in fact, you can just use this out of the box today. That's totally fine. Go to add function, look for image reference, and you can just use this functionality, which I added. But what I'm more interested in is showing you how to build something like this yourself. What this function does, in fact, let's just add it from scratch. So I'll go image reference. Is it allows you to take an image file, and I have a couple of these kind of preloaded. Let's use this one. Let's use this one. Actually, that's the same one I had. Let's use this one. And it will load in the image, and inevitably you want this image scaled to a certain size so that you can work with it. And so, this is something I wound up doing over and over again in Rhino and things like that to get, just sort of rough models out the door. And so in order to scale it, I can draw a line. I'll say, okay, I want this to be this size, which we'll notice on the drawing represents 42.8 meters. And so I can also say that line that I just drew is 42.8 meters. Oh, I'm in feet. I'm going to have to switch back. So we'll say 42.8 meters, not 42.8 feet. And now this thing should be scaled appropriately. And so I can use that as an underlay. Maybe this envelope is different than what I wanted. Maybe I wanted to like trace it, have a sort of something that's roughly the right size. And maybe I want my core to align with that. So I'll reset this core, and I could either measure it or I can just let the automated core sort of generate, and then I can modify its size. So maybe I want this to be, I'm just going to be rough for now. So you can see the utility of something like this, but this could be for an individual floor that you wanted to automate space layouts. Maybe we'll demo that a little later, or a site plan or some other reference information that you want to work with in your model. So let's build it. To start out and build a function on Hypar, we go to the kind of main page, and we'll scroll down to the area called Your Functions. And we'll create a new function. And you can create functions in Grasshopper, in C#, in Excel. We're going to do a C# function for this example. And I'm going to call it image reference. Make an image you can trace. And so I'm going to need to add a few inputs. I need a data input, which is going to allow me to drag and drop that image file. So I want to support JPEG files, PNGs. And then last time I did this, I realized that some JPEGs also have a JPEG extension. So we have to include that too. And I'll give it a name. I'll say this is my image file. Image want to load in. And then I need to specify a line. So this is the reference line. Mark a line on your image of a known dimension. And then we'll set up a number input, which is going to be the reference line length. And this is new-ish. You can actually specify in this dialog what type of information that includes, and that'll allow it to participate in things like switching between feet and meters. So it's a good idea to do this whenever you're representing a real quantity. I'll also set a medium so we can make sure, or a minimum, so we can make sure we don't have negative lengths coming in here. And I'll add in a slider for the image opacity. And we'll just say 100 is opaque. 0 is fully transparent. And that one doesn't need a unit type. And I'll set its default to 100, just so we see the whole thing. The value you set here becomes the default. And for this function, I'm not transferring data between this and other functions, so I don't need to worry about my connections. And I'm not producing any numerical outputs. I'm just producing that image, so I can leave it at that. click next, and then click publish function. And so this is gonna establish that function on Hypar and give me this little command I can run in the Hypar command line interface. So if you're not aware, Hypar lets you download a CLI tool, a little command line interface that eases the process of getting set up building a project. So I'm just going to paste that command. I already have that installed, and it's going to go ahead and create a new function for me. So it's going to create this project. It's a C# project that I can work with. And it does a bunch of automated code generation. So we've really tried to streamline this process as much as possible. So all you really have to do is write the logic for one method, and then you've got a function that works on Hypar. So this is gonna kind of set up all of the other code that needs to go around that in order for it to run. So we'll just wait for this to finish. And once we have this running, what I want to do is actually like live develop it and test it in the Hypar interface so I can see what I'm doing. All right, we're nearly there. Okay, so I'm going to move into that directory. And I'm just going to use the command line shortcut to open Visual Studio Code, which is my preferred code editor. You can also do this in Visual Studio if you would like. There's not a huge difference. So this has established all these files for me. It's also pulled in all of the choices that I just made in that editor. Things like, oh, here's the image opacity, here's the reference line length. And the magical thing is that it's generated all of these classes for me. All of this code is already written for me, which does things like establish the reference line, the image opacity, the line length. All of those inputs are just properties on a class that I have access to when I write my code. So this image reference inputs class contains all of that information. So I can use properties on input to interface with the interface that we just created here. So I'm going to click done, and I'm going to go ahead and create a new workflow. This is just going to be a blank workflow. And what I want to do is see my function in this workflow. So this is going to be my image reference example. And in order to do this, I'm going to use a functionality we call Hypar run. Which allows us to sort of locally serve our function but see it in the full context of the Hypar interface. So to do this, I'm going to go to my little user menu, test a local function, and again, copy one of these command line commands, and making sure I'm in my project directory, I'll just paste that command and hit enter. And what this is going to do is build my function and serve it up so that Hypar can talk to it. And so when I see this green ID, I'm ready to go. I can click the ready button, and I can see the interface for the function that I just created. Now, right now, it doesn't do anything, but this is a way that we can start to supply some example data. So just for fun, let's put Ian's face up on the screen. Now, it's not going to do anything with this yet.
I was worried when I saw that picture in that folder. Oh my God, what are you doing?
We're not going to do anything mean. I'm just using you as a sample image because I happen to have you on my desktop. So I have Eric's too. So if he needs to get some flack a little later, we can do that.
I support that picture with my hat everywhere possible.
I know you do. I know you do. That's why I got it ready. So
quite possibly the best GitHub user avatar ever.
In fact, you know what? Since you're a willing victim here, let's just do it.
This is so much better than any picture you're going to have of me anyways.
We'll save Ian from this. So nothing is happening yet. We need to produce some elements and return them with our output so that we see something in the 3D view. And we're going to create a texture from that image, which we'll assign to this. So the first thing I want to do is actually something really dumb. I'm just going to create a rectangle a panel, and I'm going to put it in the model. So I'll say var panel equals new panel, and I'm going to give it a shape. I'm just going to draw it as a rectangle using the polygon.rectangle method, and I'm going to have it start at the origin and go to the coordinate 1, 1. So we're just going to do a unit rectangle with its lower left corner at the origin. And that's probably fine for now. And I just have to add that panel to the model. So say output.model.add element panel. And as soon as I save this, that command line tool is monitoring my directory for changes. So it will automatically update when I make code changes. And so there's our rectangle. It's not a very exciting rectangle yet. It doesn't look anything like Eric, but we can fix that. So as I mentioned, the input object has all of these properties on it, which correspond to the inputs on the function itself. So if I want to get that image file, I can just say var image file is equal to input dot image file. And you'll see that this is an input data object, which has a couple properties. The one we care about is the local file path. Our system handles going and fetching this image from wherever it's stored and downloading it and making it available to you locally. And we're also going to need to assign a material to this panel. So I'll say var material equals new material. And I'll give it a, let's just do colors.white. And I'll just set all of these things to 0. Unlit is going to be true. I don't want this to be affected by like shading. And then I'm going to provide this image file as the texture. And
Andrew, real quick, I'm gonna make one point just about the input file location thing. I want to point out why this is cool, because people might not understand like actually what's going on with Hypar. So Hypar functions are each run individually as tiny little microservices in the cloud, right? And we talk about the scalability of Hypar, and you can spin up as many microservices as you want. I mean, obviously you don't have to worry about that, but the system will do it for you. And when you're done, it just like brings all that stuff back down. So there's never like a running Hypar up there, right? And so the complexity here is that on the user interface in Hypar, in the browser, Andrew has dropped an image file. Something happened, the system processed that image file, and then it went somewhere. You as a user don't have to care about that. But when you go to actually write your function here, you just have this expectation that the image file is going to be there when you need it. What actually has to happen is that stuff goes up to a storage location that we control. And when we actually execute your function, we go and find that file and send it down to your function so that you have it available to you in the local file space of the process that's running that function. It's kind of mind-blowing if you think about it. Like, so you could have 20 file inputs on this function that he's writing and drop different files on all of them. And we'll take care of like marshaling all of that stuff up through the cloud, through the inner pipes, and down into your function when it runs. And then as soon as that function is done running, it might get deleted and it doesn't exist anymore. And your file is still stored with us and everything else. And so that means the next time you come back and visit this workflow, the file that you deposited on there before is still there. So it saves that state that you dropped onto the function before. That means you can share this workflow, and that file, I'm pretty sure, will still be associated with it, you know?
Yeah. So let's get Eric's face on this panel. The panel constructor has some additional arguments which are optional. One of them is material, and in fact, it luckily happens to be the next one. So I'll just say, set this material on this rectangle. And if I hit save, it'll take a second to reload and recompute. But then there we have Mr. Wassail himself looking extremely dashing. So that's all well and good. We're also very lucky that Eric happens to be a perfect square. But as you'll remember, I set up—
You take that back.
Yeah.
He is a perfect square.
A perfect square. As you'll remember,
nobody who wears a hat like that is a perfect square. Let me tell you.
That's fair. That's fair. If I were to do this with an image that was not Eric, unfortunately, that was a rectangular aspect ratio, I would have a problem because it's going to squish this image into that square. So what I want to do is figure out how big the image is and then size my rectangle accordingly. And it's actually easiest. I sort of figured this out with respect to how our textures are mapped and stuff. It's actually easiest to apply a transform to this panel rather than changing the size of the rectangle you start with. So in this particular case, normally I would just say, okay, yeah, make it, make it 1x2 or, height by width or whatever.
Wait,
but the problem is
why is that?
it's gonna tile. And so I don't want it to tile. I'm going to leave it at 1, 1, and I'm going to actually stretch the whole object with a transform so that it shows up at the right size.
That is true. The default application of textures on materials is for them to tile.
Which makes sense. It's like a floor,
a concrete
wood
texture
floor
or wood
something.
texture or something.
Exactly.
Okay, I see.
So in order to get the width, I'm going to use a library that ships with elements. So you don't have to do anything special to gain access to this. I'm going to say var image equals image dot load. And I'm going to pass it in this image file. And it's going to yell at me with this little red squiggle because I don't have the reference to the right library. Up here in C#, with my using statements, I can specify which libraries I'm pointing to. And I want 6labors image sharp, which is like a cross-platform, really friendly library that comes with elements that we use to do some image-based processing. And once I have that image object, this is of type image, I can get some more useful properties out of it. So like var width is going to be equal to image.width, and var height is going to be equal to image.height. And that's kind of all I need. What I want is a sort of an X scale factor. I'm going to stretch this in the X. So I'm going to say var image ratio is going to be equal to image width divided by, or just width divided by height. And I want to stretch this thing. And so in order to do that, I'm going to create a transform that applies that non-uniform stretch. Most of the time in Hypar, we don't do much non-uniform scaling. Usually we just like scale, because very few architectural objects can just be like arbitrarily stretched, but in this case, it's okay. So I'm going to say var image transform is equal to a new transform, establish it first, and then I can apply all of these other operations like scaled. And I want to scale this by a vector that has different, this is how we do non-uniform scaling in Hypar. We'll do a new vector that is this image ratio in the X, and then 1 in the Y and 1 in the Z. So those will stay the same. And then one of the other optional arguments here on panel is that transform. So we'll just apply that image transform. And this isn't quite going to work. And the first time this happened to me, I was like, why isn't it working? Why isn't it scaling? And it's because of a very easy to make noob programmer mistake, which is that this width value is an int. And so it's an integer, it's a whole number, and so is height. And when you divide an int by an int, you get an int back. So this image ratio is coming out to be 1, even though in reality it should be like 1.6 or something. So this is solved by casting one or both of these to a double, which in C# looks like this. Probably other smarter ways to do this, but this will actually solve our problem. We should now see this stretch out to the appropriate dimension. There it is, looks pretty good. And so next I want to handle the line and line length thing, but you'll notice one other thing is that when I zoom in, it disappears. And this is because Hypar is not used to rendering very small objects by themselves. Usually there's a whole building to contend with. And so we have some sort of size limits. That's a bug that we should fix. But in any case, to get around it, what I'm going to do is just also scale this up by one more factor. So I'm just going to arbitrarily set an additional scale factor of like 30, worked well experimentally. And I'm just going to append another scale here at the end. I could also just scale these values, but I'm lazy. So we'll just say scale by our scale factor. And now it'll look much bigger, but it'll be easier to like zoom in to the size of this image and get the sort of precision that we want. And so there's my little scale marker. What I want to do is draw a line. And I can hold down Shift while I'm drawing to lock it to ortho. And I'll just draw like that as close as I can. And I also want to specify what size that represents. And as you can see, because I made this input a length, it shows me that it's in meters. I'm terrible at math. So rather than figuring out what 32 feet is in meters, I'm going to go and toggle the units for this workflow. This is a pretty new feature into feet. So I can just say, let's make this 32 feet. It's not going to change anything yet because we haven't written any code to handle this, but we will. So this is going to be similar logically to the last thing we did, which was we just scaled by a uniform factor. And the factor that we want to scale by is the reference line length dimension that we want it to be divided by the length of whatever line we drew. So that will have the effect of scaling up the whole thing to the appropriate size. I think I can just add that here to my image transform. But I'm going to do it right here because I want to handle the default case where that line length is set to 0, where you haven't specified anything yet. I want it to just continue through the way that it works now. So I'll say if my input.reference line length is greater than 0, I'm going to do some stuff to that transform. Otherwise, I'm not going to do anything. So if it's greater than 0, and probably I also want to make sure that my line is not null. I didn't do this in my example, but we will here. So input.reference line is not null. So I have both of my things. Then our dimensional scale factor is going to be equal to the input.reference line length, which is what we specified, the number input, divided by input.reference line length. And I'm just going to take that same transform, which we already established above, and imag transform, and I'm going to scale it one more time. And this, it's important to note the difference between any of these operations that have that are in the past tense versus that are sort of active verbs. This will transform this transform in place, whereas scaled or moved or whatever will return a new copy that has that change applied to it. So just a nuance you'll see in a couple places in our API. So I'm going to scale this by the dimensional scale factor. And that has actually modified this transform before we create our panel. So now if I save, it should change its size. And yeah, it looks a little bigger. I can just check that this is right by doing, let's do any old drawing function, but I'll do like an envelope by center line. And what I want to do is just like draw a line. And I just want to make sure that it looks like it's 32 feet-ish. Yeah, that looks about right. So it has appropriately scaled. We're basically done. I mean, this thing is basically ready to go. The only thing we haven't implemented yet is this opacity. So what we'll do is the opacity of a material is taken from the alpha of its color. You remember when I set this up, I made a color. I used a default color called colors.white, and I supplied that. So what I'm going to do here in order to account for the opacity is I'll say var color is equal to colors.white, or I can just do a new color, but let's just leave it like this. And then I can modify colors alpha to be equal to input dot image opacity divided by 100. And then I'll use that as my color. And now this thing should handle a variable opacity. And I probably want to, if this were a super production thing, I might want to guard against going all the way to 0 or whatever. But I mean, it does what you would expect it to do. So, I mean, we're only half an hour into this, and we're basically Andrew, done with our function.
I think no, we're not done. I think we've got to put some more cool stuff in here. Okay. Because the way that, for instance, 3D artists have done this over the years is they've put planes in multiple, they've put in multiple different planes with images on them, right? So like, could we allow the user to specify a plane? And we'll make this easy. You can be like a simple drop-down control where you can just select X, Y, Y, Z, or XZ.
I like
So a
that.
user
Or actually, I don't want to make her talk because she's popped her rib. But Serena, can you answer in the chat if do our transform inputs support our like non-XY parallel stuff?
The transform input. I don't know that it does. I mean, Serena,
it might not. I mean,
can correct me.
Because actually, that's what I did in the original version that I released. Is that I just had an additional transform input that you could modify, but I also explicitly constrained it to XY, I think. So I don't know. Do we have an answer in the? Oh yeah, here we go.
She's saying it doesn't handle different axes, but it handles skew, which would be hilarious.
That would be really wild. Let's I like Ian's idea for now, just to do something kind of improvisational. So let us, so there are going to be, there's X, Y, Y, Z, and X, Z. Do we need like all the negative quadrants, or let's just leave it at that?
No,
that
just make it simple for now. Make it simple for now.
Cool. So the way we're going to do this, so there are two ways to edit the inputs to a function. I can go find this function record and go edit it. And actually, it's probably worth demonstrating this for people because I think this is not like super well known. So here's my function in my your functions gallery. It highlights with a little pink border so you know it's been edited recently, like, oh yeah, this is the one I've been working on. And these are ordered by how recently they've been updated with the most recent first. So I'll click here, I'll go to my inputs, I'll go to edit function details, and I'm gonna add a drop-down menu. And let's just say, let's put it before opacity. So I can kind of drag from up here, drop it in. I'm using a select input, which is like a drop-down menu, and it's gonna be of type string, that's probably fine. And I'll say, we're gonna do X, Y, Y, Z, and X, Z. Our options, and we'll hit done configuring. So first,
I promise everybody who's watching, like we didn't actually sort this out beforehand. So yeah. I'm actually trying to stump the chump here. This has a high probability of failure. Although with Andrew, I don't think much has a high probability of failure.
Image path. We're not going to be wordsmithing our descriptions today. Normally, I would take a little more care. So I've made a change there, but it won't be reflected in my local function until I pull that change. So I'm going to kill this operation here. You can use Control-C to sort of kill out of this running Hypar run. And I'm going to do Hypar pull. And what that's going to do is pull in all of the new information from that I modified on the web interface. And then I'm also going to do Hypar init to have it regenerate all of my all of the like generated input classes and stuff, so that now when I go in here and I say, okay, what do I want to do with that? I can already access my orientation is going to be input dot plane orientation. It's already made it all the way to my code. It's in my IntelliSense, so I can work with that directly. So what we'll do, we want to go back to that workflow that we were using to test with. And I'm going to, let's just restart our little debug cycle. So again, that's from this menu, test a local function, grab the command and paste it. And this is going to start up our live debugging session again. Wait for it to do its thing, and then I'll hit the pink ready button when it's ready with the little green ID.
You know what's so funny about this, Andrew, is that you know, when we were building Hypar Run, we thought we were being so clever. Like, we're going to watch all the files that are code files, and whenever you edit one of those files, we're going to re-execute, and we're going to save we're going to recompile. We're going to save the compiled results to a temporary location. We're going to serve the function from that temporary location. We did all this crazy stuff. And then they made .NET Watch. So now there's actually a .NET tool. It comes in the box with, I think, .NET 5 called .NET Watch, which it's actually really cool. You can do exactly what we're doing here with any .NET command line process. So if you say .NET Watch run, in your directory. It will actually run your local project using .NET, but it will also watch for changes to the source code of that project. So if you go and change the source code, it will immediately compile and re-execute in the same way that we're doing here. We're doing a couple of other like tricky things that we need to do vis-a-vis dependency loading and everything else to make sure that assemblies loaded into the domain don't crash into each other. So I'm not sure that we can like switch out with .NET Watch quite yet, but man, when we can, it'll be like a little bit of a sad day because we were very clever about how we implemented that whole thing, but at the same time, it would be code that we don't have to manage anymore.
Absolutely. So we've loaded in this orientation. You'll see that it's even generated a type for me there. In fact, an enum type. Whenever you have a select, it creates an enum. And in fact, if I just hold down Command and click on this, I can navigate to where in my generated code, any of these .g.cs files are generated code. I'll click on this and you can see it's generated this enum for me with all of these preset values. So I'm going to operate on this based on the value of that. And oftentimes enums and switch statements go hand in hand in C#. So a switch is basically like a, if this first thing, then do this. If else this second thing, do this other thing. It's like a big chained if then where you're just testing the value of a certain property. So in this case, we just want to do a switch on our orientation. And there are going to be three cases we need to worry about. There's input plane orientation.xy. These have like kind of comically long names. And I always just kind of draft out my switch statement first and like set up all the cases. In Visual Studio, you can do this automatically, but VS Code doesn't quite have it. Image reference. What's the one I missed? XC? Yeah, beautiful. Okay. So I think what I want to do is actually, in the case of XY, I don't need to do anything because it's already in the XY plane. So that's fine. If I want to do YZ, then I think I need to concatenate my transform. And in fact, yeah, we're still before we've applied that transform. So that's good. So I need to add a new transform over the top of this. And if you're not super familiar working with transforms, some of this can take a little getting used to, the kind of transform math that Elements uses and a lot of computer graphics libraries use. It takes a little getting used to, but when you're familiar with it, it's a really, really, really powerful way to think about orienting stuff in space, you know, the rotation and scaling and, you know, all that stuff.
He is going to call this thing a plane. I know, because in Grasshopper, they call it a plane. And this boggled my mind when he first told me this. I was like, yeah, it's a transform. It's like a coordinate system. He goes, you mean a plane? I was like, no, a plane is like, you know, an origin space and a normal. He's like, well, that's what they call it in Grasshopper. I am right now calling on David Rutten to come on Hypar Live and explain to me why a coordinate system is called a plane, please.
Yeah, I mean, it makes sense to me. It's a little coordinate frame. Yeah, it's a plane. Why not?
But a plane is a plane. So what do they call a plane?
There's no data type for like an infinite plane. It's the same thing. They use it for that too. So like if you wanted to like intersect a bunch of planes with
it has orientation. Like a plane has no orientation. So okay, continue.
Anyway, so what we're going to do is construct yet another transform, and then we're going to add it on to the one that we created before. Just like we did here, we kind of like added a scale over the top of the transform we had already established. So I want to create a new transform, and I'm just going to call this var YZ orientation is going to be a new transform. And there are so many constructors on transform, and I can never remember which one I want to use, but I think the one I want is the longest one, which is this one, where I have an origin, an x-axis, a z-axis, and a rotation. So I'm going to have to do a little work here, but let's just populate this. The origin is going to stay the same. I only want this to alter the orientation and not its location. So that one's easy. Next, I want the x-axis of this transform, which is kind of a funny concept. So like, what is the orientation of this thing, which in this case, let's just have it be y. So we'll say vector3.y-axis. This is just a built-in constant. And then we want the oh, I guess we can do X, Y, and Z. That would also work. Or we can do X, Z, and rotation. So let's do X, Y, and Z. We're going to have to do a cross product one way or the other. So let's do X, Y, and Z. So I'll do, we want the y-axis of this transform to be the world z-axis. So that's vector3 dot z-axis. And then we want the z-axis of this transform to be whatever third vector is perpendicular to those two. So I could do a cross product, or this is not such a hard thing to figure out. The one axis that's perpendicular to these others is vector3 dot x-axis, and there's some chance that I'm going to have to negate one of these, but we'll figure it out when we get there.
I totally deep six this whole presentation by making you spend 20 minutes talking about transforms.
Yeah, you did a little bit. It's all right.
But so for those of you who are watching, actually, the 3D programmers actually spend a lot of time looking at either their left hand or their right hand. So Hypar uses a what's called a right hand coordinate system. If you kind of make like a gun like that, and you stick your middle finger kind of pointing out like that, and then you point your middle finger up like that. This represents how Hypar sees a coordinate system in X, Y, and Z. And it also has the interesting effect that if you take the cross product of this vector and that vector, you get this vector. So doing this stuff a lot, like if you ever need a mental model to figure out like what's going on, you can like point in a direction and then say, oh, right, if I take that vector and this vector's cross product, I get this vector over here, right-handed. Some systems use a left-handed coordinate system, and don't even get me started about Z up or Z forward. That's a whole other thing.
So, all right. Well, Ian, for your transgression, I'm going to make it your face this time. So
I don't even know what picture. Oh, that's not a terrible picture. Okay,
we've got you on the XY.
I need a picture with a hat.
We've got you on the YZ. That's looking pretty good. And we've got, I think this one, I mean, depending on how you're looking, this is either correct or flipped. So we'll call that a day. I wanted to show one other thing. So we'll leave it at that. But now if you really want Ian's smiling face hovering over your model, you can make him really big too by saying that the distance, the width of his neck is like 300 feet. So then he'll be.
That's to scale, by the way. Yeah, I'm exactly. Enormous.
If you haven't met Ian, he's a giant.
Larger than life, they say.
Okay, so I wanted to show like a practical use for this. I recently released a video that was taking advantage of this functionality, and I think it's pretty cool. So let's actually just kill this debug session. I'm just gonna reload here, and I can kill this guy as well. I'm gonna load in the version that I already wrote, but it's basically equivalent. I do need to add one more thing to this, which is that when you're done debugging and you actually want to make this available for people, you have to do Hypar publish. And when you do that, it will take all of the code that you just wrote, package it up, put it up on the on Hypar server so that it's available to start just you. Everything starts out private, but if you build a feature that's really cool and you want to make it available to folks, you can go into the permissions tab and make it public. So I'll just make this one public as well. Now you can play with either version, which will be a little confusing. I'll delete one of them eventually. So having built this, let's take this one, which is the one I prepared in advance. I'm going to load in one of these. In fact, let's use that one, this kind of silly looking office building that I pulled up here. We're going to actually put this to work. And we are going to take this very janky core and shell drawing that I found on Google image search or whatever. Also, we're going to need to switch back to metric because I believe this guy is in metric. So we'll draw a line and we'll say this is 42.8 meters. Whoops, 42.8. And I want to like lay out an office in this core and shell. So let's just actually, yeah, let's do it like this. We can either start with the template, but since I'm already here, we're just going to do this. So I'm going to find space planning zones. There's also, if you want to build out this, I'm using the functions that constitute what we call Hypar space, which is a tool. for doing kind of automated office layouts. In fact, you know what? Let's actually just use the template. I think it'll be easier. So when you create a new workflow, you can choose Hypar Space as one of the options. It has little instructions that kind of guide you through getting started. And this is an example of a workflow where you might want to drop in one of these image underlays. So let's just do the same thing I just did. We'll drop it in. And I'll go find it over here in my workflow panel, and I'm going to drag it in here. I'm going to have to reset the scale, but no big deal. We're in meters, so that's good. I'll draw the line, and we'll set this to be 42,800 and 42.8 meters. And now I'm going to proceed. I'm going to close this guy out. I'm going to proceed to just set up a floor that kind of follows this boundary. I sort of demoed this a little bit at the beginning, but we're going to take it a little further this time. So I'm going to draw, whoops, I'm going to draw my little rectangle and hit save. And we also want to make sure that the core is the right size. And so I'm going to make floors by sketch. I'm going to put it in show as context, so it's a little bit translucent. And I'm going to go to core by floors and edit. And let's just pull this guy down to here and pull these guys down to here. And then I'm going to be loose about this. Just, I mean, if you were really doing this as a project, you would obviously care a little bit more about zooming in and getting those right corners, but this will be close enough. It's going to automatically generate a corridor system, which is just a simple ring because this is just a simple square. I can manipulate some of the parameters that control like how deep it is on either end. So let's say that we've got some like, I don't know, 4.8 meter depth over here. And then these other ones are going to be like maybe, yeah, I don't know, 6-ish. So this is just controlling how far these corridors get offset from the floor boundary. This looks pretty good to me. I'm also going to tell it to do something other than put desks in all of these spaces. So as you can see, it automatically assumes open office for everything as just kind of like a default. If you want it to assume something else, you can pick from this menu, but we're going to leave it. And I'm just gonna assign some things. So I want 2 bands of private office on kind of either side of the core. So we'll drop that in. And I also probably want some conference rooms somewhere. And you know what, let's, I think I may have made my core like a little big now that I look at it. Let's see if we can get our core in context mode as well. No, it looks about right. So we'll leave it. And I just might pull this dimension back a little bit so we have a little more room for those offices, because right now they're looking a little tight. And if they're too small, they won't be able to like get furniture generated automatically. There we go. So on this side, it's put in kind of single offices, and on this side, it's put in shared offices for 2 people. It uses the available space to decide how to populate the furniture in each of these spaces. Next, we're probably going to want some way to get out of the core. So I'm going to need another corridor. So let's just draw some corridor points. I'm going to do one here and one here. That should handle inserting some new corridors. And now I'm just going to kind of carve up the space a little bit further by inserting a few what we call splits, which will just take these kind of monolithic volumes and split them up into smaller pieces so that we can assign a more like refined set of program. So let's just do some splitting. I know I'm going to want like a sort of a triumphant conference room on this side, and maybe some smaller ones in a couple other places, and maybe a reception over here, and maybe like a pantry over in this corner. And maybe this will be some lounge space. I mean, I'm not an interior designer for a reason. This is probably not a very good layout, but it's up to the user to make those decisions. So now that I've inserted those splits, I can get in here and make some choices. Like maybe I want some kind of little couches or social space here. I definitely want like a big conference room right here. Maybe I want another let's see, let's find like a kind of smaller conference room we can drop in here. And I think I wanted a pantry over here. Let's just see what that, oh, and I think let's do like a reception desk right here for when you're entering. Let's see what that does. So I probably need some more detail over here, but I've got my little reception desk. I've got some little table and chairs, sort of social spaces. I've got my big triumphal conference room. I probably want a couple more meeting rooms maybe on this side. So let's just drop in, like, let's kind of do a bank of like 4 meeting rooms. That's probably good. So we'll do, actually, we'll use that one too. Why not? Set these to be meeting rooms. And, you know, so in the space of, I don't know, 6-8 minutes, we were able to take this image of a core and shell plan and create like a complete 3D model of an office that, you know, we've got all our metrics. We can figure out how many desks we fit in here. I'll just pop that out. We've got 132 desks. Maybe I want to study like what would it look like if we used slightly larger, different desks. I can go down to my open office function and say, let's try like L-shaped desks and let's see what that does.
Andrew, it's probably worth pointing out, like people might be watching and saying like, well, PDFs are so like old school. I have like Revit models and everything else. But for those of you who have worked in the sort of owner operator space or in the real estate world, oftentimes for existing like assets, existing buildings, they don't have any digital files. You know, the building was built 30 years ago. You might have like a plan that was scanned at some point in the past. And how would you do like a test fit in a space that doesn't have any kind of DWGs, DXFs, Revit files, IFC, any of that stuff? You know, you basically have to trace over CAD. So some of you have probably done this exact exercise before.
Yeah, I mean, when we released this tool, it was one of the #1 feature requests was like, well, you know, sometimes I have CAD or a Revit model to start with, but a lot of time I just have like a scan. Is there any way that we could, you know, use that as the starting point? So that was part of the motivation for doing this. And, you know, if you haven't seen this before, one of the other nice things is that you can import this directly into Revit. So if I won't demonstrate the whole thing now, but I can just export this as a JSON file, and then the plugin that we have in Revit will be able to translate all of these objects into native Revit elements. So you will actually get all of the like steel case families that we're using instantiated in your model. And, you know, but in a way that's much easier to work with in this context where you can quickly test out alternatives. Like here, these are all of the possible desk sizes. And in fact, we're just about to add a bunch more desk sizes. I can just quickly flip through these options, generate a few alternatives, see how these are doing against my metrics. And maybe I want a version that has more private offices or a version that has less. And, you know, bang that out in an afternoon rather than, you know, having the intern in the office do all of these test fit layouts for, you know, a week before you get the result. So this is just an example of what you might do with something like this image underlay. But I think there are lots of examples. You know, we could drop in a site plan and then model up a whole building. But let's leave the remaining couple of minutes for any questions. I think I've been bad in ignoring the chat. But anything interesting come into the questions?
I've just noticed, of course, that I've been sending all my messages that were directed at, for instance, Praveen to the panelists instead. So I was actually responding to his comment. So we had a great question here that's about point cloud data. Do we support importing point cloud data? And the response that I gave to the other Hypar panelists, which was totally useful to everybody else, is no, we don't yet. But a number of people have asked us about this because that is another very common format for existing assets that people are doing right now, which is they're scanning floors. And we should, you know, there's no reason why we shouldn't be able to handle that aside from the size of the point cloud data. So it doesn't really map well to any of the structures that we currently have in our libraries for generating the 3D assets that we use on Hypar, but it should be relatively straightforward to do. And I know that other people have done it with some of the underlying technologies that we use. So if you're really interested in point cloud data, reach out to us directly, connect with us on Discord. bug us, because you're not the first person who's asked that question.
Yeah, and I'll share the Discord link in the chat as well. Feel free to join us. It's a great community where, we're hanging out all the time. We're always available to answer questions or get you pointed in the right direction if you're interested in trying out Hypar. It's also a great place to just talk about the future of the industry. We have really interesting folks coming in and talking about what machine learning and other things mean for, where the AEC industry is going. So there was a question about MEP plans or elevations as well. I mean, I think, this technique here would work well for bringing in any image-based information. We also support dragging and dropping CAD files. So I don't have any examples handy, but you can drop in a DXF and use that as a sort of scaled underlay. And of course, if you have existing conditions modeled in Rhino or Revit, you can also bring those in, and those actually become 3D entities, and you can, have functions that react directly to that geometry. There was also a question about 3D printing. We haven't seen too many 3D printing use cases from this, but there's nothing technically preventing it. And I also think that one of the things I've always dreamed about is, when you have a detailed model, super fine, elements and stuff like that, but you want to make a quick, 3D print to show to a client, there's no good way to at least that I know of, to automatically thicken everything to the minimum dimension that a 3D print needs to be. And that's a perfect candidate for a Hypar function. You could just write a function that looks at all of the building elements in the model, measures their minimum size, sizes them up if necessary, and create an STL file that you could download. There are a few things we would need to build in order to support that, but the basic functionality, I think, would not be hard to add. So we're out of time. I'll stick around a little bit in case there are any last questions, but for everyone who joined, thank you so much for coming. I hope this was useful. And Dan is raising his hand. Hey, Dan, you are now permitted to talk. Oh, are you muted?
But will he?
No. Oh, it was a mistake. Oh.
Well. No, you have to talk now.
Yeah, now you have to. You can just say hi.
Oh, hello, hi. That was a mistake, but hi. This is amazing. Thanks for doing this.
And thanks for coming.
Yeah.
Thanks, Dan.
There's also a question in the question answers. Will the material properties be preserved when it's exported to Rhino?
Yes. We maybe don't support textures yet. But yeah, material certainly, colored materials certainly come through to Rhino. We haven't even talked about our Rhino import yet, but it is in the works and coming soon, I think. And yeah, it supports the basic texture and material functionality that we have.
I mean, if you just export the model here, if you just pull it out as a GLB or a GLTF file, of course, all of the material properties, including the texture information, is encoded in that file, so you can drop it into other 3D viewers. But for Rhino right now, the import-export workflow is a very specific calling their APIs to convert things.
Yeah.
So we'll support textures, I think, at some point.
And Brittany had a question about a kind of floor plan generative solver within Hypar. And this is something we've been talking about a lot lately. I have often sort of gone on the record as saying that I'm more interested in direct manipulation than full automation or sort of fully generating a solution. But I actually think with tech like this, we're pretty close to being able to say just the steps, the sort of interaction that I did here, where I was splitting up the plan a little bit and assigning programs. We do have a mechanism for you to define your program requirements. So if I wanted to, specify specific programs, and in fact, I'll turn on something sneaky. You didn't see that. I can even upload where do I have it? Office plans, I think, or Hypar space. Somewhere on here, I have on my messy desktop, don't judge me. I have some example CSV files. So you can actually upload a whole program sheet. Oh, here we go. So if I take this, I can specify what my program targets might be for this project. And then I could, let a solver try to satisfy them in assigning these things, and then just rely on all of the rest of, this workflow to kind of automatically figure out all of the furniture and stuff like that. So that's definitely something we're starting to think about. And we built some functionality around this in other contexts for sort of private customers. So it's definitely like technically possible.
And Andrew, I'm glad you have this up on the screen. It's a little bit off the topic of the earlier presentation, but Anthony and I were just talking about this earlier today. In the context of having like a general schema for program requirements. I've seen architects build their own version of this thing. Like in every architecture firm, it's like a little bit different. But because we're now starting to encode functions that actually take these program requirements, we have our own version of a schema because we have to do what Andrew is showing here on the screen. But we would be really interested to get feedback from architects about how they encode their programmatic requirements, because programmatic requirements are very complex. It's about, how much required area, but it's also about adjacencies and everything else. Like, how do you describe that? If we could come to terms with that and like come up with a schema that everybody could use, then you could have that thing coming out of whatever your planning tool is that you use could generate a piece of data that you could drop right onto Hypar and have it do this generative process. I think talking about this, Brittany, in terms of, how do we develop that data payload to give to Hypar so that it could do this stuff is probably a really interesting conversation to have. Because there's no standards that I've seen. Maybe somebody else knows more than I do, but I haven't seen like a standard for how people define program requirements.
Yeah, no, I mean, in my experience, there's like, there are like so many other things in the industry, there are like a million closely guarded Excel spreadsheets, which are like my secret sauce, my special version of
which all say the same stuff.
Yeah,
it's all just like a list of here's the types of spaces, here's how many square footage I need of those, here's some adjacency requirements. We've seen a bunch of these.
Yeah. And I think one thing we've been talking about that I think is a necessary step for some of this stuff is just being able to like maybe have one layer deeper of grouping, like being able to say, okay, all of this stuff fits under meeting room, and there's some way to kind of like nest that stuff. That is the next level of complexity that I've seen pop up quite a lot with some of this stuff in practice. So we'll be looking at all of that. But Mayur wants to know, does the interface allow parametric control of numeric values from CSV? So, I mean, everything is a parameter here. So, I can get in and manipulate this value. Currently, we don't expose it in the same way we do, like, a lot of our parameters have this sample range capability, where you can type in, 4, 5, 6, 7, and 8, and it will generate all of those options in parallel, and you can kind of pick which one you want. Currently, we don't support that for the kind of input from a CSV, but there's actually, the only reason we don't is because it would be too crowded in the interface. We just need to find out a good interface solution for it. All of the underlying tech would support that, no problem. So I guess I'm curious, what would the use case for that be, or how do you imagine something like that being used? I think there's no reason technically why we couldn't support that.
We also have a question on the YouTube chat that I'd feel like answering there from John Manicherry. Two
great.
questions. Hi, John. First is, what is the ideal pipeline from the current model to any real-time render environment?
Oh my gosh, John. You had like a bug on the wall in the Hypar offices these days. So I have specific opinions about this because I'm like a game engine guy from a long time ago. And I think the pipe we already have, for instance, the hub technology that we use with Revit, which allows us to connect to Hypar workflows as you're actually working on them and as they're executing, and stream down the visualizations that you're seeing here. And we use industry standard formats like GLTF to make that possible. So a connection to a real-time platform, a Unity, an Unreal, any one of those would be as simple as kind of repointing that kind of technology at those at the frameworks inside those platforms to do the same. We did a little demo for Unity actually of doing exactly that. We just like hooked up using our API to a workflow that we were editing in real time, and stuff was just streaming down and being dumped right into Unity. And we did relatively little Unity work because GLTF is now more widely supported, and it just kind of looks right when you come in. You got to fiddle with lights and everything else, but so there's definitely something we're going to do there in the future. We don't know exactly what platform it's going to be on or anything else, but I think it's a pretty straight path technically to get there.
And he has a related question to, which we have a good answer to, I think. When will Hypar natively support textures and displacement mapping, et cetera?
Well, when will it natively support textures? I guess is that from John as well?
Yeah,
it is.
I don't know what native means. I mean, it can speak to displacement textures. So displacement textures actually don't exist in the GLTF specification, which is how we encode all of our 3D data.
Although we do have bump maps, right?
We don't. So displacement textures and bump maps don't exist anymore. What they have in their place is normal maps. So which is not a displacement map, it actually just changes the kind of the look of the texture. So what we'd have to know, John, is, and you can obviously reach out to us directly on any of our social media and ask this of us directly. Like what effect are you looking for? Are you actually looking for actual displacement? Because for instance, we have the location function, which allows you to pull down Mapbox data, part of which is like topography. The way that we do this, we actually sample images and then construct a mesh based on, because they don't have displacement maps as a thing in GLTF. And they're not also supported from the GLTF loader in 3JS, which is the framework we use to actually visualize this stuff in 3D. 3JS does have its own version of a displacement map, I think, but we don't take benefit of it because we come in via these GLTFs. So yeah, but I mean, if you have like a specific use case, reach out to us directly and show us what you need.
I think it's worth highlighting that the normal map stuff like does look pretty good. If you're just talking about like, you know, a fabric texture or, you know, a wood floor or something that's just, you know, even some like reflectivity stuff, like it looks pretty good. It's definitely an improvement over just like a flat image map to something, but it doesn't do the like, you know, the actual 3D bumping.
Yeah, we support everything that's in the GLTF 2.0 specification. If you go out and look that up, and all the stuff that's supported thereby in the 3GS framework for the GLTF loader, except for animations. We don't support animations. I would like to, because I think there's a lot of really cool stuff that we could do with animations, but we don't support it yet.
There's another question from Mayur in the chat about, can anyone install any library and develop functions on top of it? And the answer is yes, any library that you want that's .NET Core supports can be brought in to your function. So you add it as a NuGet package, like you would to any other C# project, and you can utilize that in your functions. And there's like a massive ecosystem of really cool C# libraries that you can rely on for that.
Now, the two that he's asking about specifically, ARKit and Keras. Keras, yes, possibly, because we have the capacity to do Python functions. It's not widely disseminated that we have the ability to do Python function because we sort of standardize around C#. But we're actually doing some internal work right now on machine learning libraries and integrating those as Hypar functions. And those all use Python. So Keras, probably yes. No, I'm also following along here, Meyer. Thank you for the continuation of that question. Python library using IronPython, yes, because they just released IronPython 3, which is compatible with the .NET standard that we now use. But to get back to your question about ARKit, probably, if you're talking about the iOS ARKit, then no, because it has to be iOS. And we're certainly not supporting anything Objective-C-ish.
and in fact, I have done Keras on Hypar. So
there you go. Yeah, Matt.
We've already done Keras on Hypar. There you go.
All things related to ML frameworks. So
cool.
that, by the way, Meyer, I should point out, I'm sorry, one more point. That's an amazing use case for a function. Trained machine learning models as a function on Hypar is incredible. And I hope that in the very near future, we'll have some specific examples that we can show of that. So if you have a trained machine learning model that you want to deploy as a function and you want to know how to wrap that up and how that works, let us know.
Absolutely. And he's volunteering to be a beta user which is great. Yeah, I mean, we'll keep that in mind. So yeah, I think we'll probably wrap it up there. If there are more questions or you're just curious about anything else on the platform, I think Discord is a great place to join us and join in on the discussion. We're all super available and easy to talk to there. And yeah, thank you for coming. Thank you for sticking around a little extra. Yeah, maybe we'll see you at the next one or see you on Discord.